Hi, welcome to my kitchen. Today we are going to talk about the gas CO2 and how it makes bubbles and fluffiness in our baked goods. So we're going to start with some muffin mix and then we're going to move to pizza dough. So I have two batches of muffin mix for my morning muffins. They have carrots and apples in them. And they're different size bowls, but the same amount of muffin mix. Now, oftentimes in muffins, you're going to see two different leavening agents. Those are going to be the things that make it rise. I've already got one leavening agent in here, which is eggs. And then we have two options. We have baking powder and baking soda, which look very similarly, but baking powder, if you look carefully, has sodium acid pyrophosphate, sodium bicarbonate, cornstarch, and monocalcium phosphate. So that first one I said, sodium acid pyrophosphate, is often known as cream of tartar, and it's actually an acid. So in this dry powder, there is an acid and a base, and when they're mixed into something that has water in it and heated, they produce carbon dioxide. And those little carbon dioxide bubbles expand in the oven because we know that volume and temperature are directly related. So if I heat up the gas bubbles that I'm about to make in my muffin dough in the oven, then the volume of those bubbles is going to also increase, which gives me nice fluffy muffins. So baking powder has both an acid and a base in it. Baking soda is just sodium bicarbonate, which is just a base, which is why when you add too much of it, you get kind of like a bitter off taste in your baked goods. It's not great. First, we're going to put baking powder in both of these. And then in this one, we're going to put baking powder and baking soda. And we're testing for two things. First, we're testing for whether or not the baking soda causes the same amount of leavening as the baking powder alone. The baking soda, instead of having an acid-base reaction that creates gas, is actually going to just decompose. It's going to go through a decomposition reaction that produces carbon dioxide gas that is also going to produce bubbles. The second thing that I'm interested in here is that I recently read that baking soda can create the Maillard reaction. So the Maillard reaction is any time that you stick something in a hot pan on the stove and it gets brown, what's happening is that amino acids are meeting sugars that are in your food, and they're creating all sorts of yummy flavor molecules. It's really essential to a lot of depth of flavor in a lot of foods. And I recently learned that baking soda apparently can help that Maillard reaction happen. So the batch of muffins that has the baking soda in it, in theory, is going to be browner on the outside than the batch of muffins that doesn't have the baking soda in it. I don't know if that's the case, and actually this particular muffin recipe usually comes out a little bit too dark on the outside, so my goal is to avoid the browning, which is not usually what we're looking for. Usually you want lots of browny, tasty bits. But in this particular case, I want to know that if I leave out the baking soda, will my muffins be less brown? Let's try. So I want a half a teaspoon of leavening agent in both of them total. So in this one, I have a 1/4 teaspoon measure here. I'm going to add 2/4 teaspoons of just the baking powder. And in this batch, the larger bowl, I'm going to add 1/4 teaspoon of baking soda and 1/4 teaspoon of baking powder, and then I'm going to mix those in. Okay, to go over that, in this batch of muffins, we have baking powder. In this batch of muffins, we have half baking powder and half baking soda. We're looking to see if this batch of muffins also rises, which would tell us that the baking soda does in fact create bubbles through a decomposition reaction. And secondly, we're looking to see if the baking soda causes the Maillard reaction, which is going to cause this batch of muffins to be darker than this batch of muffins. Let's call these guys batch A and these guys batch B. Okay, second project of the day, pizza dough. So I have all of my dry ingredients mixed, and this recipe calls for 1 cup of water, which is a little bit cold, so I'm going to warm it up. Okay, in this case, instead of getting carbon dioxide bubbles that fluff up our baked goods from an acid-base reaction or the decomposition of sodium bicarbonate, we're going to get it from the digestion of yeast. And so in order to get my yeast to be awake and happy, I need to wake them up. So I'm going to pour out about a cup of water, and that's the reason the water is warm, is because yeast work faster in warmer environments. The yeast are going to eat sugars that naturally occur in the flour and produce carbon dioxide gas in the same way as your body using sugars to create energy and breathing out carbon dioxide gas. And heat causes that metabolism to happen faster. That was only 1 teaspoon and I need 2, so I'm going to measure out another teaspoon of yeast. But what we usually do with yeast is wake it up first. And so I've got warm water. It's going to bring it back to life. It's in dormancy, and that's also why if you have yeast in a big jar like this, you're going to keep it in your fridge because that's going to preserve it for longer and keep it alive but dormant for longer. Okay, so I'm going to mix these guys up just a little bit. Make sure everybody's bubbling. So this serves the purpose as much as anything else to verify for me that my yeast is in fact still alive and is going to work, because no one would want to start a recipe and go through all the work of kneading the pizza dough and then have it not rise. So in addition to getting cloudy, we also see bubbles forming. It looks like little bits of foam almost. And I'm going to go ahead and pour this into my well-mixed dry ingredients. I'm going to use my other water to kind of rinse that out and make sure I get all of my yeast. So we were talking about gluten development. So if you can think about gluten as a bunch of stringy molecules, when they get tangled up with each other, they kind of get woven together through the process of kneading the dough, which is what I'm doing right now. They become stretchy, and that stretchiness, much like a balloon, can contain larger bubbles of gas produced by our yeast. So whereas the carbon dioxide bubbles in our muffins will be relatively small and uniform, a pizza dough, for instance, might have large bubbles and smaller bubbles. And those large bubbles are going to be enabled by properly kneading my pizza dough. So I've got everything incorporated here, and I want to show you a technique for deciding whether or not I'm going to show you a technique for deciding whether or not your dough is properly developed. So if we take the dough in between our fingers here, we can see that it pulls apart relatively easily. I can't make long, stringy things with it. Now I'm going to take some time to properly knead this dough, and then I'm going to show you what the dough is capable of doing after we've kneaded it. Welcome back from the kneading break. So, before we talked about gluten development, now that I've kneaded this, I have a fair amount of gluten development. So you can see there my dough reached its stretchiness mark and it pulled apart. But what it can do, that my muffin dough certainly cannot do at this point, is get stretched out to the point where it's actually almost see-through. So that's one way I can tell that I've done enough kneading that this pizza dough is now ready for the yeast to do its work. We've got a couple of hours until dinner time here, so what I'm actually going to do is different from what you might, I don't know, normally do with pizza dough. And that's that I'm going to put this in the fridge where the yeast is actually going to work slower because it's at a lower temperature. And over that time, that allows the yeast to do a secondary job, which is to release some other flavors into the bread as it's fermenting at a lower temperature. So the longer the bread ferments, the longer I leave it in the fridge, the more sourdough-like taste the pizza dough will take on. The shorter I do it, the more it's going to taste like, well, pizza dough. Or at least, I don't know, very plain. I'm going to bake things now. Hi, and we're back with muffins from the oven. So, baking powder, and baking soda. Two big differences. First, the baking soda seems to work faster than the baking powder. So you can see here where the baking soda muffins have a nice round top on them, whereas the baking powder muffins seem to be just kind of flat on top, and they didn't really move out of the shape that they had in the muffin tin. So when I looked at them when they were in the oven about halfway in, these guys were much bigger than the ones with just baking powder. So to me, that tells me that I should use a mix of them. Our second question was about browning. Does baking soda actually make your baked goods brown more? Which in this case I wanted less of, but most of the time you do want browner baked goods because it's tastier. And it does. I don't know whether or not that's going to come out on camera, but the baking soda muffins are definitely way browner than the baking powder muffins. So I hope that was exciting and interesting. We talked about 3 sources of CO2 gas that make the bubbles in our baked goods. Baking soda that works via decomposition of the baking soda or sodium bicarbonate. Baking powder, which has baking soda and cream of tartar, which is a acid-base reaction that also produces CO2 gas. And then we talked about yeast, which is going to produce CO2 gas through the digestion or metabolism of sugars, which we use to capture by knitting together those gluten molecules and making a bread that can stretch. All right, I hope this was fun for you. I'm going to enjoy a muffin now. Bye.